Yep. Okay. So on this, let's see if this works. Oh, did it again. There we go. All right. So let's talk about foundations. As I mentioned before, in chemistry, science is very foundational, where you start with the basics. So with chemistry, we said there are elements and there are compounds and there are mixtures, right? And then finally, at our last test, we found that you were actually predicting products, right? We throw chemicals together and you're predicting products, you're figuring out the ratios of those products to reactants, and so on and so forth. And if you didn't get the foundation down very well, it was very, very difficult to do well on that final exam. Okay? So same thing with physics. It's going to start out relatively simple. Today we're going to start out with motion, and eventually we're going to build on that more and more and more. And if you don't get the foundation, it's going to be very difficult to get the tippy-top stuff because it's based on the earlier things. So if you find that as we go along there's anything you don't understand, make sure you take time out of your busy schedule and lives to go ahead and understand what's going on. Okay? So, the first thing we're going to do is we're going to talk about frame of reference. And frame of reference is used anytime you're talking about motion. You use a frame of reference because it's motion relative to something else. And that something else is your frame of reference. So, when you see Mr. Schuth walking across the classroom, my Amisha would say that Mr. Schuth is walking in which direction?
Right.
To the right, because her frame of reference is herself. Now, on the other hand, if I'm walking this way, and Mr. Schuth would say Mr. Schuth is walking in what direction?
Forward.
Forward, because Mr. Schuth's frame of reference is Mr. Schuth. Let's do another thing. How about, let's say that Gabby is on an airplane, and she orders a soda from the stewardess. Yes, I'd like a soda, thank you. And she puts a little ice in it, and she puts the soda on her tray table, and she looks at the soda, and she can reach out, she can grab the soda easily because the soda's not moving. What's the frame of reference here? The plane. The soda's moving just as fast as the plane is, right? On the other hand, Johnson happens to be at the airport watching planes take off and land, and he sees Gabby's plane go by as it circles. And how fast is that soda going relative to Johnson?
As fast as
It's going fast, right? Hundreds of miles an hour. So, the frame of reference in that case is Johnson, or his frame of reference is the ground, right? Most common frame of reference is going to be the Earth, but it can be any frame of reference. So you're always measuring motion relative to something that is assumed to be stationary. Okay? So motion is measured relative to something that is stationary. Now as you go out, you always know that things are moving, because we normally say it's moving relative to the Earth. Right? Or the Earth moves relative to the Sun, but we know that the Sun is also moving, and so on and so forth. Everything is always in motion. It's always relative to something else. We just assume it to be stationary. And that's our frame of reference. So when we say that the Sun rises in the east, what's our frame of reference?
facing the ground.
The ground, which is the Earth. It seems to rise. Is the Sun really rising? No, but it appears to. Okay, so motion is measured with a frame of reference. The very basic thing for motion is distance. So distance is just measured from one point to another point. And that motion between the 2 points is known as the distance, and it's measured in meters with an M. So like I said, it starts out pretty easy. You're like, oh yeah, I know distance is meters, no problem. But stay with me today. We're going to keep adding to this. Yes, Graham? Common frame of reference. Yes. It's not.
Assuming.
It's not. We just assume that it is stationary.
Where it's all going.
190 miles an hour.
Right? Okay. So that's what frame of reference is. You pick an object. You say that object is not moving. This other object is moving relative to it. Normally the object that's picked is the Earth. We say the Earth is not moving. But we know that the Earth is rotating once a day. Right? So we're going hundreds of miles an hour just as we rotate on our axis. Does it look like we're moving? No, because our frame of reference is the Earth. And relative to the Earth, we're not moving. Right? Okay, so that's how that works. So distance is measured in meters. So from here to here is a certain distance. We're okay with that? Now we're using the SI system of units. So that also means that we can add prefixes and suffixes. So if we said km, then what does that mean? Kilometers, which is 1,000 meters. Right? What if we said cm? What's that going to be?
Centimeters.
Centimeters, which is 1/100th of a meter. So those are most common ones. Meters, kilometers, centimeters. Okay with that? Okay. So, the other D word that we need to talk about is displacement. Displacement is one that is used sometimes in the common vernacular. In fact, let's take a moment to talk about that. In physics, it's really easy. Physics is so easy. The problem is, common vernacular has taken a lot of physics terms and twisted them and made them wrong. Alright, they're used incorrectly. And you'll find that when you turn on the TV, you watch a movie, you read a newspaper, people get it wrong as far as what they've taken, their idea of what it is, and made it wrong. Alright? And that's sometimes why people have difficulty in understanding physics, is because all that they've learned right is wrong. And it's really hard to go against that. So you'll find out sometimes we'll be talking in this class, and you say, that doesn't seem right, because all your life you've been taught wrong. And it's going to hurt to try to rewire your brain into thinking differently. So that's the hard part of physics. After that, it's all easy. It's only taken me 10 years to rewire my brain.
Only 10 years. That's
Yeah,
not too bad.
so don't worry about it if you're still hurting by the end of this year. All right, so displacement. Displacement is simply distance and direction. So it's from point A to point B with the direction. All right? Displacement, by definition, is distance with the direction from your starting point. So let's take a couple examples of that. Well, before I do an example, displacement, since it is a quantity with a direction, it has a unique term to it. Anybody recognize quantity with a direction? Yes? Right, quantity is amount, but when you take a quantity and add it to direction, anybody recognize that combination? Vector. So quantity with a direction is a vector, and we'll use that term several times in physics. A quantity that has a direction is a vector. Alright, so let's do an example for distance and displacement. Let's say Mr. Shoes starts in Indianapolis, Indiana. Come on. That's where we are. That's what Indiana looks like. And we're here right in the middle, of course.
Oh my god, it's the first letter of my name.
We're going to drive to Chicago, which is, let's say, 250 miles. And then we're going to drive to
Michigan.
South Bend, which is, oh, let's say, I don't know, what, 150 miles, just say? Probably not. And then we're going to drive back home, which is another 200 miles. Now, the question is, what is Mr. Shoe's distance that he goes, and what is Mr. Shoe's displacement?
600.
So how do we find the distance?
Adam.
You add them. So we have 250 plus 150 plus 200, that's going to give us what?
600.
600 miles. We're okay with that. What about displacement? Yes? Distance from Indianapolis, which is?
250.
Negative. We went from Indianapolis to Chicago to South Bend to Indianapolis. How far away from Indianapolis are we?
Nowhere.
0. So our displacement is 0. So, when you're running track and you do the 400, the 800, the 1600, the 3200, your displacement is 0. You're back to where you started from.
So what if we're running on the track and we start a little bit ahead?
That's different, isn't it? Well, it's the same distance, right? Okay, so let's try another one. Instead, we're going to go back to Indiana.
It's improved.
Not too bad, huh? All right, so we're going to go to Chicago. Let's say that's 250 miles. And then we're going to go over to Fort Wayne. Let's say that's 200 miles. So, let's do it again. What's our distance? What's our displacement?
450.
So distance is 200 plus 250. That's going to give us 450 because we've traveled 250 there, 200 there. So 250 plus 200 is 450 miles. Displacement. How do we figure that one out?
200.
Ooh, Colin. How do we do it?
Yay!
Exactly right. So we say, okay, let's see, that's A, that's B, so this is C, because displacement is from your starting point. So in this case, we're looking at C is going to equal the square root of A squared plus B squared. Everybody's happy with Pythagorean at this point, right?
Yeah.
So that's 250 miles squared plus 200 miles squared. And take the square root of that, and that's going to give us what?
6500 plus.
It's 320.15.
320? 320.15 miles. Now notice it's miles squared plus miles squared, and square root of miles squared is miles. So,
No, it is miles in an absolute value.
okay, so this is 320 miles. Now, is this a distance or is this displacement?
Displacement.
That's a distance. Displacement needs a
Comma.
direction, so we would say northeast. Right?
Wait, what about the first one?
Now, what about this? Mr. Schuth is right here in front of my Mistra. Mr. Schuth moves over here in front of 90. Right?
Right.
What's Mr. Schuth's displacement?
Left.
About a foot. And
1 desk.
left.
Left. Okay? So it could be left. It could be towards Grandma's house, right? It could be towards the Albany's Candy Factory, which we'll talk about later. So, direction doesn't always have to be a cardinal direction. It could be up, it could be down, it could be left, it could be right. It could be towards something, away from something. Right?
Forwards, backwards, sideways.
So, make sure displacement has a direction. Alright, so let's talk about speed.
Yay.
No, not that kind of speed.
What is velocity?
So speed is simply a ratio. What's the ratio for speed? Ratio of what to what?
1 to 2.
Oh.
It's distance to
Velocity.
Exactly, distance to time. Distance to time. Let's see if we get